Hi, everyone. Wow, that was quite the introduction. So hi, good evening, everyone. I'm also excited to be here today. Here is wherever I am and you are, and talk about something that is near and dear to my heart. And this is really the connection between this wonderful technology called AI and us, people, humans. As Louis said, my name is Ruth Kikin-Gil. I'm a designer. I lead responsible AI practices in a Microsoft organization called Security, Compliance, and Management, which is roughly 3,000 people around the globe. And I want you to meet this person. His name is Professor John McCarthy. And he was one of the forefathers of AI. He was the one that coined the term artificial intelligence back in 1956. And then he defined the subject as the science and engineering of making intelligent machines, specifically intelligent computer programs. And ever since, we're all chasing this vision of super intelligent being that people build. And they made it so much better than what we are that it just took over the world and obliterated everyone, right? But if you look at AI today, it's really just a really fancy name for a group of technologies that are one-dimensional. And each one of them may excel at doing one thing pretty well, but their abilities are limited to a very specific context. And moreover, most of the AI products that are out there right now, it's not one algorithm, one model that is doing everything. It's really a chain of different models. Each one of them is doing their own thing and sending the results to the next one. And there's someone, a person, sometimes many people, that decide what that end-to-end experience is, what that what's the end goal of that feature, that product. And when we're looking on the difference between traditional programming and machine learning, in traditional programming, the code is a definition of rules, and they're written by a person. And this code is applied to data, and it uses the rules to calculate an answer. And the results are predictable, they are repeatable, right? That's the whole idea. In machine learning, the algorithm, which we also call the model, analyzes past data and then analyzes the resulting answers. And then it produces rules, new rules that sometimes we couldn't figure out traditionally. And the human is the one that collects the data and gives the model a group of examples. And then the model infers rules and applies them to that new set of data. So here's an example. Let's say we want to train the model to recognize muffins. It's a very important task, right? So we show the model lots and lots of different pictures of muffins until it learns what muffins look like. And this is called training. And then we can ask, is that a muffin or is it a chihuahua, right? And you can see that there's never a conclusive answer. There are always probabilities. There are some of them are probability that are closer to 100%, and maybe some probabilities are lower, but it's never 100% of certainty. And this is really depends on how good was the training set. The market share of AI is rapidly growing. In 2018, it was roughly $20 billion, and the prediction is by 2026, it will be $200 billion. And this is just, I don't know, 5 years from now, even less, right? We're at the end of 21. It means that even if you're not already working on something that's related to AI, you'll be doing that in the near future. And AI can do really exciting things, right? It can generate human-like text, like in this example, or it can create some fantastic images and art by combining different styles. It's called style transfer. You can even ask it nicely to design apps for you. In this case, this very talented designer, programmer, Jordan Singer, trained a model called GPT-3 and created a plugin that allows him to just type in what he wants to that plugin to create. And in this case, this is something that resembles Instagram, right? It can edit video with text. You can tell him, you know, take out the text, it will edit down that video. You can create your own deepfakes, you know, for $29.99. All this amazing thing is yours. And it can do so much more, right? It can identify security breaches and develop drugs and identify skin cancers and create games and more and more and more. But as we all know, it's not that simple. Everything is complex. And there are some challenges for designing for AI-infused systems. And let's unpack some of these challenges. So the first thing is that AI is probabilistic and it's prone to errors. And about 2 years ago, there was this huge weather forecast that in Seattle, I'm from Seattle, so we had a weather forecast that there's going to be a huge snowstorm that is going to bury everywhere, and that it's going to be like the worst storm that we've ever known. So everybody was panicked, and you couldn't get kale in the supermarkets because it is Seattle. And everybody waited, kind of braced themselves, waited for this horrible storm. And then the snow came down and was like that for like 2 days, and then it stopped. And as you can see by this t-shirt, we all survived, right? Now think about the weather forecast as a metaphor for AI systems. It looks scientific, it is, right? And therefore reliable. Wrong. And we as designers, we need to design for this tension of what we think it is, or what's the projected image of that feature, that product, and what it can actually deliver. And we need to convey the predictions in the way that will communicate clearly to users that this is not the absolute truth, right? That this is maybe high probability, but it's not 100%. And this is something that both weather forecasts and most AI systems today really fail to do. The other thing is that AI learns and changes over time. And this is the big promise of AI, really. This is the core thing. We put something out there, it gets feedback loops, it gets more information, and it grows and it changes and creates beautiful things sometimes, but not always. So in this case, a reporter got pregnant and she started posting stuff on her social media. And sure enough, she started seeing all these ads about being pregnant. And then something tragic happened and she lost her baby. And she kept seeing those ads. And she told that site, well, I don't want to see them anymore. And then the site said, oh, she doesn't want to see them anymore. She must have had a baby. And then she started seeing all these newborn ads, which made everything really worse, right? So what I want you to take away from this story is that we can't just leave algorithms out there and say, okay, they will learn and evolve and it will be wonderful, because it won't always be wonderful, right? You have to monitor them. You have to think, okay, what could happen and how can we make sure that even after they're out there, we can still control them. Same way that you would do with a child, right? You wouldn't just let a toddler go out there in the street. The common discourse about AI is that it's a hard technical problem. But the truth is that it's also a hard human problem because it touches everyone in our society. And the question is, what will help us take a human-centric approach to developing AI systems? And how can we make sure that we're always thinking about people first, right? And this is something that as designers, we do well, but not everyone does. That's one thing. And the second thing is sometimes just the fact that, hey, this is a shiny new technology kind of stops us and say, oh, okay, that's the technology. It's not always the technology. It's really the people. And I want to show you this.
Camera, I've got a face. Can you see my face? No glasses face? You can see her face. What about my face? Well, I've got a mask. Can you see my mask?
Yeah, so this is Joy Bolangwini, and she's one of the founders. She's the founder of the Algorithmic Justice League. And what you see here is really a project that she did when she was a student, and she was playing with AI and computer vision, and she discovered that computer vision algorithm couldn't see her, couldn't recognize her, right? Basically erased her because of her skin color. And I do recommend that everybody watches the movie Coded Bias. She's kind of one of the heroes of this movie, and it's wonderful. But one of the things that came out from this very poor experience was that she created with others this Gender Shades project. And this project looked into computer vision algorithms and the way that they recognize people, men, women, different skin tones. And what they found out in that project was, and they looked at different common models. And what they found out that was there always a difference between the accuracy of how computer vision systems recognize white men and Black women. And in some cases, it went up to 34%, right? So this is really erasure by the algorithms. And if the computer vision algorithm can't recognize you, right? Everything that comes with it, all the features, all the wonderful things that we are promising that are built on that technology, you can't enjoy it. Kate Crawford said, what's interesting about training data sets is that they will always bear the marks of history, that history will be human, and it will always have the same kind of frailty and biases that humans have, right? So when you're thinking about a model, an algorithm, it's not just the technology, it's the people behind the technology that created that as well. So let's take some look at other fails of models and systems. So again, facial recognition. This man was wrongly accused by an algorithm for being a robber. And one day he was with his family and the police shows up and takes him to the police station. And it turns out that there was some footage from a store where some jewelry was taken, a watch was taken, and the algorithm that analyzed that footage decided that this is the man. And he kept saying, no, it wasn't me. It really wasn't me. And no one listened because they had evidence, right? The algorithm said so. And then they actually looked at the pictures and found out that there was no resemblance, right? Except from the fact that the other man was Black as well. Another fun thing around fairness and inclusion in ads. So Harvard law professor, Latanya Sweeney, discovered that her name invoked ads that imply that she has a criminal record. And the fun fact was that she found it during an interview with a reporter. And that man was typing her name, was Googling her while he was talking to her. And then he said, yeah, but what about your criminal records? And she said, what? And he showed her, you see here, all this Latanya Sweeney arrested. And then she dove deep into this area and found out that names that are typical Black would invoke this type of ads, whereas names that were typically white didn't, not in these numbers. And then, fairness and inclusion in ads, it turns out that men get more kind of wealth building ads than women, and that Black people see more ads about renting apartments, and white people get more ads about buying houses. So this is all about opportunities, right? What you can't see, you don't know about. And then autonomous cars, we talked about algorithms that don't recognize Black skin. And this is a problem when you're trying to cross the road as a Black person or dark-skinned person. And then there's problems with identifying cancers and skin diseases, which work much better for fair-skinned people than Black-skinned people. And you can see that this article on the left is from 3 years ago, and this one is from this year, and seems like nothing much is changing. And then problems with inclusion in recruiting. Women's voices, female voices are being less recognized by a lot of the assistant systems. There's lack of transparency with AI assistants. And this is a fascinating example where you can see here, this is the stop sign and someone put some stickers on it and it looks pretty benign, right? But actually this is a research where the researchers hacked the signs, and these little stickers that you see up there are really changing what the computer vision algorithm is seeing. And instead of a stop sign, it says that the speed limit is 45 miles per hour, which is very different and very dangerous. So I hope you understand by now that my big concern is not that we're going to die by malicious killer robots that are coming after us, right? We're going to perish from neglect and from not paying attention to the impact of this plethora of small machine learning features and different functions that surround us. And responsible AI is already a concern. You can read here, nearly 9 in 10 organizations across countries have encountered ethical issues resulting from the use of AI. And this is from 2 years ago. And the same research shows the other side, right? It says, well, ethical AI interactions drive consumer trust and satisfaction. So if your feature, if your product is the perception is that it is ethical and that the interactions are ethical, people trust your brand more. They recommend it to friends. You can see the difference in the NPS score, right? There's greater loyalty. So this makes a difference. Melvin Kranzberg said that technology is neither good or bad, nor is it neutral. So the way to think about it is really to work from values and work from principles. And responsible AI is really about creating those principles and putting them into action. And what you see here are Microsoft 6 responsible AI principles: privacy and security, fairness, transparency, accountability, inclusion, and reliability. And each one of them has a very specific definition of what that means. I'm not going to go into that, but if you're looking at other companies that have developed principles, they're very similar, right? And the responsible AI, or we call it RAI as well, pillars are that it's human-centric, it's principled, built on top of these principles, it's collaborative, all the disciplines working together, it's proactive. We're not waiting until something happens. We are always kind of on the lookout for what could go wrong. We're always thinking about what harms could be introduced by what we're doing. And then it's contextual. So it's all about the scenario of use. If I'm trying to log into my computer with facial recognition software, this is fine. But if I'm using the same software to recognize, identify people in a demonstration and then be able to, throw them to jail, maybe not so much, right? So always think about the scenarios of use, because this is super important. And like I said, responsible AI is not just about data science. It's about all disciplines working together. And this is really important because as a designer, you might not be exposed to the data science side, or you might not understand it. And this is a really good opportunity to start reaching out if you are working on some AI-powered feature. Get educated about what the other side is doing and make it your side. Try to work together. So it's PM and data science and design and engineering, user research, content writers, marketing, customer service. Everybody should work together. And it's good both for understanding, what are the harms that a feature could have or a product could have or introduce, but also how to mitigate those harms, because you can solve things in different parts of the design process. And not all of them are in the model side. There could be a lot of mitigations that happen in documentation, in the user experience. So if you're all working together, all the disciplines are working together, there's a huge advantage to that. And there are tools that are available for each one of the stages of the product life cycle. Now, if you want to activate responsible AI in the organization, you need to, and this is super high level, right? But you need to build responsible AI leadership. So in my organization, I'm part of that leadership. And what we do, and this is kind of the middle point, is understand, part of the things is to understand what do people in the organization know, what they need to know, what kind of education and training they need, but also where are the gaps, right? And what do they don't know? And then how do you implement that in the product teams? This is very important. Make it part of the way that the team works. And to do that, you really need to assess what's the impact of that AI feature that you're introducing, looking at the end-to-end scenario and consider all the implications. What are the benefits? What are the harms that could happen and kind of weigh both of them one against the other and see, are you creating something that is more positive? And then after you understand, okay, these are the harms, you start thinking about, okay, how do I mitigate them? What's my plan? How do I release that thing, right? So what is the minimum bar that beneath that this is not going to see the day of light? And once you understand that, think about what are the different mitigations that you need to do to make sure that you are shipping the right thing to the world. And the last thing is the ongoing evaluation. Like I said before, you can't just put it out there and say, oh, okay, I'll see you around. You need to keep a lookout for things that could go wrong and listen to your customers and listen to feedback and make sure that as much as possible, when something bad happens, and always something bad happens, you're prepared. And now I want to zoom in to the Human AI Design Guidelines, which is a tool that was developed in Microsoft to think through the design of a product. Because the good news is that issues that are caused by AI frequently can't or don't need to be solved just by algorithms. They can be mitigated by good design. So a group of many people from all around Microsoft put their heads together and say, okay, what can we do to make sure that we are connecting this high-level principles into the actual reality of creating a product? And out of this thinking came the guidelines for human AI interaction. And these are a distillation of 30 years of industry and academic research. And we took very wide array of papers and academic research, industry research, took it together and created this set of 18 guidelines. And those guidelines provide recommendations on how to create meaningful AI-infused experiences that leave users feeling in control and that respect their values and their goals and attention. And you can see that they are divided into 4 groups, and each one of the groups is more important in one stage of that relationship between the AI product and the user. And there's a Kai paper of how it was done. You can read it, but it's not about academics. It's really about what we're doing. So let me show you some examples. So the first group is really about the beginning of this relationship between people and the system. In that case, make sure how well the system can do what it do. So this is all about setting expectations. And the example on the left, you can see Facebook is using a very humble language, and it says, hey, these are people you may know. It doesn't say, oh, this is people you know, it's not for sure. It doesn't know, right? So it's being very tentative about it. On the right, you can see Zoe. It's a social bot, and it's making typos. It's doing typos on purpose. Why? Because it knows, the creators knew that it's going to make mistakes eventually. So let's prime the user to the fact that this is not a perfect system. And then what happens during interaction? In this case, you might know this example. This is a notorious CEO query. And what used to be when you're looking for CEO was you would see a group of mostly white middle-aged men, right? If you wanted to see something else, you could see that in the sub-queries. Now, this principles, it's about mitigating social biases. And that felt wrong to the people in Bing. So they grouped together designers and user researchers and data scientists to figure this out. And after a long process, this is what you see today, right? And you can see how way more diverse this group of people is. And everybody here is, again, a CEO. If you want to see just male CEOs, you can still do that for sure, but you have to go to the subqueries. And then my favorite, what happens when you're wrong? We're always wrong, right? So this is about supporting efficient correction. If you're inserting any image into Office, you get automatically what we call alt text, which is a description for people who are low vision or blind, and it helps them understand what they see in what others can see in that picture. But sometimes it's AI generated, right? We get it wrong. So there is an option for you to go and change it to whatever you want. And then last but not least, what happens over time? In that example, this is encouraging granular feedback. And this is super important because it really closes the loop. It helps us understand where we're being wrong. And then hopefully the system, if it's built correctly, it can take that feedback and improve the algorithm, retrain it. So you can see on the left, there's a case where I'm getting an email helping me prepare for my day, and this meeting that I'm about to go to, it found this one document that might be connected to it. So, but it doesn't know for sure, right? So it asks, is that related or not related? And if I as the user interact with it, the system can improve. So this is one, this is great. The second thing that we would encourage you to encourage granular feedback is because the more that you get the user to engage with your system, right? If they're clicking this buttons, this means that they are investing in what you're offering them. And if they're invested, they'll come back. So think about it. So you've seen examples for what the guidelines look like. But then, okay, that's great. Why should we care? Well, after the guidelines were created, we were curious to know, how do users react when a certain guideline was applied or not? And we call it a violation. And to measure the impact, we ran a series of studies that try to assess the guidelines' effect on business goals and success. And we took the users through a series of experiments to understand how the guidelines influence the perception of products. And in each experiment, we asked the users to evaluate features when the guidelines were applied or violated. And what we found was that the features that apply the guidelines consistently performed better in metrics that are connected to successful products. Things like people tended to trust them more, and they felt productive, felt in control. So if you're interested in that, pay attention. And what we did to bring this into the product is really going with teams through a workshop that has a component of learning, some practicing, and then bug bash. And if you're not familiar with this term, the bug bash is an event where everybody sits together, has some scenarios to go through, and trying to basically break the system and try to see where things don't work. And every time you find something like that, you file a bug. So we created a workshop, a 3-part workshop, where we did 3 things. One, defining what is the core set of guidelines that is relevant for this feature. and then audit that with some sample scenario. And the third thing is this bug bash. And the important thing about narrowing down to a core set of guidelines is because 18 is too much, you know, nobody can hit 18 guidelines, and sometimes you don't, they're not, some of them might not even be relevant to what you're doing, right? But five-ish is a good number. This is what we're using. And it's also about commitment of the team for resources, for people, for funding. So it's really important that all the core people on that team will be behind that set of guidelines. So here are some examples. If your feature is about notification, then timing services based on context is really important, right? If you're trying to send an email and you forgot the attachment, it's a good time to remind you. Others, maybe not so much. Or if you're creating a recommender system, making clear why the system did what it did is very important. If Office is recommending some files for you and you say, oh, why am I seeing this? Oh, because so-and-so mentioned you understand. Even if you disagree, right? You can still understand why the system did something. And in that case, people tend to be more forgiving. So but you don't get to the 5 immediately. First, we get to the top 10. We vote on the top 10, right? And then we take those top 10 and we are working through a sample task, sample scenario, and going screen by screen. And for each one, these little numbers represent the numbers of the guidelines. This is literally what we were doing. We're just dragging them into the place in the interface. Anyone can do that. We are collaborating on a PowerPoint file. And then people say, yeah, I think that this has been violated because, and we are having a discussion together. And that together is really important, again, because this is a practice and this is how everybody learns how to recognize these violations or applications of the guidelines on the scenario that they are working on, right? So that you can think about it as a cognitive walkthrough with some added elements. And then each participant selects their own core set. And you can see these are real examples from a product. There are variations. And what's interesting is that we are having, again, a discussion as a team, and people explain why they thought that that was their top 5. And people change their minds. You can see, because we're doing it again in a collaborative way, you can see how people swap the cards into something else. And this is an example for a final set. And that is the commitment, right? This is what the team, as a team, is committing to. And then we go and we start doing the bug bash. It could be on a real product if this has already shipped and we're looking at a shipped product and looking on how to improve it. Or it can be prototypes or walkthroughs that the design team has put together. And during the bug bash, we're doing it in Azure DevOps. You can see that we're tagging each one of the bugs with the appropriate tags, with the guidelines and with the responsible AI tags, so we can look at them later and create queries to see later on how the team is doing in accomplishing all that. And this is how we make that connection between something that is very high level, the principle of inclusiveness, for example, or fairness, into something that is super practical, that a dev can go and fix it and understand what they're fixing, and the designer understand what they're doing there. Everybody understands. So some final thoughts. First, AI is awesome, right? It can do amazing things. But it's also a hard human problem. And we need to remember it's not just about the technology. It's not about the technology, it's the people, right? The people in front of the technology and the people behind the technology. And we need to pay attention or we are going to perish from neglect, right? It's like death by 1,000 paper cuts. And to achieve that, we need to work from principles and values, because there will always be biases, and values are the opposite of biases. And people are talking about AI as the new electricity, the thing that really powers the world. Well, if AI is electricity, then responsible AI is the insulation tape. And that's the thing that makes sure that the stream, the current is going to the right way and it's powering the right things, but it doesn't cause harm and people don't get hurt from it. And now this is time for some questions if you have them.
Hi, Ruth. So I was taking a couple of notes on questions that came in the chat. So, and if I mispronounce anybody's name, I'm really sorry. But first, before I get to the questions, thanks for the presentation. Like that was really cool. It got the brain wheels going. So Charles is wondering, so Charles mentions that all the limitations of AI perception, like when you're talking about like the heart monitors and things like this, right? The AI perception may be even more problematic in countries like Brazil, where it's truly a mixed population and with various skin tones. How can responsible AI work in that setting?
So it's about data sets, right? It's about making sure that you are including diverse, I will call it specimens because it doesn't have to be people, right? It depends on whatever it is that you are trying to achieve. In that case, you know, in facial recognition or in computer vision, you're talking about people and the need to identify all people, right? So you need to have examples of all people, right? Whatever that means. And this is really important, you know, if you can, like there are classic cases of I don't know if you know about the racist dispenser, soap dispenser. So, you know, you can see the YouTube videos of people trying to get the soap out and they have dark skin and it doesn't come out, right? And their friend, white skin, no problem. And it's kind of a broken world, right? If you're living in a place where you cannot get services, if you are being assessed for things, if you are being erased, and there are all kinds of examples, like I think it was Wozniak that applied for a credit card or a credit limit, and he got a certain amount, and his wife, and they have shared property, shared credit cards, also applied for the same thing and got way, way less than he did, right? Mm-hmm. And the entire system is built on models and algorithms that say, oh yeah, that has a certain risk level, that has certain risk level. Mm-hmm. And we believe them, you know, we believe the algorithms. I don't know if we trust them, but we don't bother to check. Mm-hmm. And this is one of the things that I'm trying to get through, is that this is all built on probabilities. We know that we're going to fail. This is the kind of the working assumption. This is the thing that if you're talking to data scientists, they are looking at their false positives and false negatives and trying to figure out how can they create something that minimizes both and is accurate and it it can identify all the right cases, and they can't. No one can, right? So I'm not sure it answers the question of, oh, okay, what can we do with Brazil? But this is what we should do everywhere. And pay attention on how we're building those data sets. So we can say, okay, step one, we know what we want to have in that data set. And this is where user researchers can come into place and kind of define, do the research and define what does the data set need to look like, right? What are we looking for? What are we trying to achieve?
As a researcher, I love hearing that. Right? Say like, what'd you say? Say it again.
I'll say it again. I think that this is, to be honest.
Once more for those in the back, right?
I think that this is an emerging profession, to be honest. That intersection of data scientist and user researcher, where you are, and if you're coming from the user research side, you might not need to know everything about building the models, but you have to have enough knowledge and understanding on what is needed to build a model. And you need to have that kind of business understanding of what are the goals of that feature at the end, and then use all your skills of user researchers to go and define what that data collection needs to look like, and how can we make it so there is a correlation between the users at the end that will be using this product or will be affected by this product, and the initial set of people that we are recruiting, or initial set of information that we are recruiting in the beginning for the data set.
And I feel like that addresses, so Chris asked in the chat, and I see everyone's questions in here, so we'll get to them, like I'm trying to kind of weave them in, but Chris had
I don't see the chat on my end.
Oh, okay. It's on the bottom. It sometimes pops up. But so Chris had asked, how do you scale responsible AI beyond individual team workshops? And I feel that your mention of data scientists working with user researchers kind of addresses that, but are there other things that you can do as well?
Oh, yes, for sure. This is my day job. It's a huge thing. It's a big thing. You need to, it's first and foremost, it's a culture change, right? You need to help people realize that that the way that they are creating products is changing. And the tricky part is to see which parts of the existing processes, the existing things that are already happening in a specific company or a specific product culture can be enhanced, not replaced completely as much as possible, because the less people need to learn new things, it's better for you, because then you can really focus on the things that are the delta. And then the other challenge is really understand what are we doing here? What is responsible AI? What are the different tools, different techniques, different things that we want our people to use? And there are lots of them, and the entire area is pretty much in its infancy, right? So there are different levels of maturity of different tools, and there are tools like FairLearn or InterpretML that are looking at fairness in models. There are ways to look at adaptation and kind of use that as a tool to at least message some of the things to users. Think about transparency, both to the data scientist, both to the end user, to the designers, understanding what's going on. we also found that there's a thing about responsible AI. No one will tell you, I don't think it, I think it's a bad idea, right? Everybody say, yeah, we should definitely do that. We should be responsible, right? And then you say, yeah, great, here's all the things you need to fund. And then they say, well, we have this and we have that priority. And it goes from the top to the bottom, right? Like if you're going to someone on a product team, or if you're talking to leadership, basically the first reaction is, yeah, let's do it. And then I said, well, so part of the work is really to make that gap smaller and to make things super concrete for everyone. And make them understand, okay, this is the next thing that I need to do. And one of my big challenges is that there's a lot of things around responsible AI, which is about compliance, right? There are rules, there are regulations. China just came up with their own AI regulations based on human-centered principles. Super interesting. I didn't read through it yet, but I'm really looking forward to it. But then the truth is that it's not about compliance. It's about doing the right thing, right? So my goal is to inspire and to make people aspire to do the right thing, not to comply to regulations. And you can compare that to accessibility, where you can go through the checklist of the WCAG2 and check all the boxes and still have a shitty product because you didn't really think about the users and designing for them, right? And you didn't do it the right way. But if you're thinking through the inclusion lens, then you will check all those boxes, but you are looking at the experience, not at the boxes. And this is my aspiration for responsible AI. And really the best outcome would be if in a few years that will not be an issue that anyone talks about. It will be just, this is how to work, this is how we design, this is how we create products, and it's kind of the substrate of everything.
Kind of a no-brainer. So I want to be cognizant of time. So we've hit the 7 o'clock mark. Luis, I don't know what the agenda was looking like after 7. We still have a few more questions that were coming in, but it's up, like, you're running the show. I'm just moderating the questions.
I will leave it up to Ruth if she wants to spend some more time with us. How do you feel?
Yeah, I can answer 1 or 2 more.
Okay, so I'm gonna kind of pick and choose a little bit. So there was one that came in about your thoughts on the ethics of AI as applied to the financial sector. It's kind of that could be a spicy take. And if it is, we're here for it.
Yeah. I would like more guidance on answering this question because so big.
Yeah, so so ethics of AI is applied to financial sector. So sometimes you see, and Catherine, if you want to chime in here, more than welcome to. I'm assuming that it's like approving people for credit cards, financial things like that. Not sure. I don't know if she's still on or not. Looks like she's not. Yes, that could be. Okay. But she is here. Okay.
Yeah. It is so when we are looking at harms and dangers that is coming from AI, this is one of the big ones, right? Like if we are doing things that put people at harm because they don't have access to resources, or because resources are allocated differently because of who they are as part of a certain demographics, right? This is something that is happening over and over again in many sectors, including the financial one, right? And the results can be devastating. And again, it's the same rules that apply everywhere. And I think that there is something tricky when you're thinking as a designer and you're saying, well, you know, I really, it's not me who's creating those models. It's not me who's doing these things. I'm not making maybe the decision at the end of it. But I want to talk to you, you know, as people, right? And you're working on something. And I'm looking at you, Carol. I don't know if you see that I'm looking at you, but you're the only person with video here. So you're my victim.
Oh,
you know, you're looking.
Luis was hopping on for a second. There he is.
Oh, you know, you're working on a feature. Ask questions. You know, if no one else is raising their hand and asking questions, be the person that asks questions. And if they're telling you, oh, okay, so just to design this risk score visual here because we want to show people that this is their risk score for, I don't know, for credit, or ask questions. Okay, so how do you know that? You know, what are the ingredients? How did you get there? And kind of get to the bottom of things. Talk to the data scientist.